Okay, so today's topic is circles. So, circle, you must have heard about the geometry, okay? Geometrical shapes. So, we have gone through, we have seen many shapes, okay? We daily see the different shapes. For example, if we are seeing a book, okay? Suppose this is my book. So, this is one kind of shape, okay? Which is quite possibly a rectangle. Okay. Have you seen a chapati or a roti, right? You daily eat it. Okay. Chapati or roti, maybe. Okay. So these shapes have got like very much significance, and we will touch upon that in the introduction of it. And these days, if you see, okay, so this is a circle, then ये circles है एक तरीके का. Okay. So if you see a block cart, okay, okay, if you see a bullock cart and if you see a wheel, okay, so very important thing is the wheel. What is the shape of a wheel? It's a circle. Okay. So of course it is in 3D,
Yes,
but if you
sir.
see the 2D, if you see, it is a wheel. So wheel is a very important discovery, okay, for mankind. So if you see the, in the ancient times, we used to have bullock carts, okay. Prior to that, even the bullock carts were not there, but when the bullock carts were there, the wheel was there, okay. And even these days, if you see the automobiles, so you will see the wheel, and wheel is like synonymous with a circle, okay. So that is why if I feel like we have a chapter for this circles, so it has to be there, okay, because circle plays a very important part. But in a day-to-day life, where are we daily using it? If you see the chapati, in at least in Indian kitchen, in Indian households, our mother makes like chapati or roti daily, okay. So that is the, it is not like the very common shape of the chapati is of a circle, okay. It has a circular shape. And if you see, suppose you see a thali, okay, always remember, कभी एक थाली देखना, okay, this is a thali, okay, this is circular, and inside that if you have like different katoris, okay, if you see a Maharashtrian thali, there are many katoris in that, okay, many utensils, they are also circular. And then you have a chapati also like this, okay. So all these are circles. So have you ever given a thought why are they circles? Generally, if you buy these utensils, so you can get other shapes also, but very common prevalent are circles, okay. There could be a relation to surface tension, okay? But at the broader aspect, at the energy level, if you see, these are circular shapes. And if you're standing over here, suppose, okay, and it is the daytime. So you see Suryadev is there, okay? तरीके से तो उनकी शेप क्या है? At least the shape that you perceive in your eyes, okay? वो भी circular shape है, okay? ठीक है? ये शेप हमारी भी सर्कल है, okay? If you perceive, if you see the moon, okay, you might like see several things on the surface of the moon from here itself. But if you see on the broader terms, you'll see the moon also as a circle, okay? So in our day-to-day life, there is a kind of a resonance. This is called the principle of resonance. Later you'll come to know, okay? So everything is resonated. So our rishis were that intelligent, they used to know, and that is why the Indian food is like that. All the utensils, okay, handis, etc., they have the like circular thing, okay? And all these heavenly objects that you're seeing, they are also like you will see them in circular shape because it's a sun-based system on Earth at least, okay? So if you'll see, you will always see a circular shape, and that circular shape is constantly getting inside you in your subconscious mind. Whenever you see something, okay, whenever you see, because in ancient times the technology was not that much, okay. We used to just see the heavenly bodies in the night. We used to see the moon in the day. We used to many times see the sun, okay. So both were those shapes. That is why all these shapes are constantly going into our subconscious minds, and that is how they are like coming again in different forms. So in Indian food system, if we see, so whatever the utensils were there initially, they were earthen pots. Now also they are coming again. Okay, and they were very healthy also. So they also have the mouth. If you see the mouth of it, okay, so that is also in circular shape. All the handis, etc., they are also in circular shape. If you see the small katoris, small utensils, they are also in circular shape. Okay. Nowadays we use steel, and generally, I mean, if you see the earthen utensils, okay, earthen pots, like small earthen pots, and if you see the chapati also, it is also the same shape. Though it is not that much refined, it is not that much precise, but it is generally the trend, and generally the shape is of a circle. Okay, so whenever you see a chapati, again you always think of a circle. So circle plays a very important part, okay? Automobile, if you are having a bicycle, for example, okay? अगर आप लेते हो कोई भी है ना, ठीक है? So even in a bicycle, if you see, wheels are circular. And if they are not uniform, since they are uniform, so our motion is becomes very easy. When we ride a bicycle, okay, we just cover quite some distance in less time. The time that if we walk through it, okay. So it's a kind of a machine. Bicycle is also kind of a machine, but generally it is possible only due to a wheel. And wheel, if we see from the study of it, from geometrical shape of it, it is a circle, okay. So circles are everywhere. Even if we see a raindrop, okay, which is falling off, ठीक है, इस तरीके से हो जाती है वो generally. But if we see, they have also like a spherical shape. If you see the 2D of 2D shape of it, okay, ideal raindrop. Otherwise, when it is coming down, so it is elongated on the one side. So they also have a circle. Okay, the circles are everywhere. Okay. But have you seen these days? I mean, if you go to a farm, or if you have a farmhouse, or if you are doing any farming, so if you see the shape of the shape of your fields, they are rectangular. They are not circular. Okay, because if we have a circular fields, then the area in between them, it will be, I mean, management wise, it is much better to have the rectangle shapes. Okay, otherwise in day-to-day life you use, okay, if you are using a glass also for having a water, so the mouth of it is also mostly they are like circular shape. Okay, so this is basically on the principle of resonance. So some kind of resonance is there. So when a Rishi used to know about that principle of resonance, so what they have like inculcated in our daily houses, okay, the food system, the thali system, okay, every other thing, the chapati, etc. So daily you are having the resonance with the sun, okay, heavenly bodies. So because they are also getting inside your subconscious mind, and that is how daily you are seeing that. So circle is a very important shape. It is a smooth shape. It does not have the corners. So if you see from the scientific point of view and from observation point of view, if you see this thing, okay, so it has four corners. Okay, one, two, three, four. While if you see a circle, it has no corners. Okay, it is smooth. Smooth, or you can say aerodynamic. Aerodynamic, okay, ये हो गया. And if you think, suppose you have got a pebble, okay, if you have got any pieces, any stone pieces which is not very smooth, and if you put that inside a river, you just this is a thought experiment. This is actually real-time experiment. So if you put that, okay, and somehow trace that thing, and you must have gone to Rishikesh and other areas, okay. So when the river Ganga is there, if you like pick up any stone out of it and you see the smoothness of those stones, and they've become very smooth. Okay, initially they were like cornered. Okay, if you put any cornered stone into that, and years later, if you trace that stone, you will find it aerodynamic. Okay, so nature is like not cornered approach. Okay, nature has a smooth approach. So over the time, everything becomes smooth. So the same goes with our subconscious mind also. For example, you are having certain experience inside your, it goes inside your, it is stored there. Okay, that energy is stored there, and later when as and when your life passes, you'll see that you'll gain some kind of experience. Okay, out of it, some kind of a uh, some kind of uh, knowledge maybe. Okay, that is very essential for your life's learning. So whatever maybe many times you have the cornered things in your subconscious mind, but as and when you grow, as and when you pass your life, okay, so the life also chitta dhara jo bolte hain, the chitta is also like a river, flowing river. Okay, so as and when it is flowing, so all those experiences in your subconscious mind, they get smoothened. Okay, and you become a balanced person, you become a very uh, your like journey towards becoming a balanced person is like that. Okay, so everybody has to live his life, and that is how they are gathering the different experiences in their subconscious mind, and as they are living, they are getting smoothed. Okay, so nature prefers that smooth outline approach or aerodynamic approach always. That is what I have seen. Okay, so now let us see some of the things. So there are three concepts. Suppose if I am having a line and I am having a circle. Okay, so I'm showing this in one figure only. Just see that. Suppose this is a circle. Okay, and this is line, some line. This is first line, and this is second line. Okay, and there is like, or you can say this one is the third. Okay, this is another line. Yeah. Okay, suppose if you see, this is the first line, maybe suppose this is the second line and this is the third line. Okay, so if you see the first line, It is outside the circle. It is not intersecting the circle in any way. So that is called as non-intersecting line. Okay, this one is non-intersecting line. Secting line. Okay. Next one, touches the circle. Just touches the circle means it has only a single point of contact, and this is called as tangent. Another one is inside the circle, cutting the circle at 2 points. Okay, what are those 2 points? These are those 2 points, and this is called as secant. Okay, 3 scenario है ये. Now whichever line cuts the circle from inside, if it is passing from the circle, if it is passing that circle from inside, so it will always be called as a secant, because it will have 2 points only. And once you go out, once you take that line out, okay, and so at one point of time it will touch the circle at only 1 point. Okay, you can say the line and the intersection point of the line and the circle is only 1 point. Okay, so that is called as tangent. And another one that is lying outside is called as non-intersecting line. It is just any line outside the circle. It is not doing anything. Okay, it's not touching the circle at any point. So we can also say that a tangent is a very special case of a secant. Okay, when the two endpoints they become one. Okay, so these are the naming conventions. Now we'll see. What do you think? Chalo, this is okay. Now we'll see. Basic convention of a circle. So circle always have a center point. So if this is O, then O is called as the center of the circle. Okay, center of circle. Getting it? And if we draw a line from center to anywhere, okay, to the outer periphery of the circle, so that is called as R. Okay, so R is the radius of the circle. Getting it? Radius of the circle. Okay. What do you think if I like draw a radius, suppose here, will they be equal or will they be different? What do you think? Will they be equal? If I draw any line to the surface anywhere on the circle, will they be all be of equal length or will they be different? Okay, they will all be equal. So that is the definition of the circle. So now if we take a practical exercise, suppose you are there maybe, okay, and you've got a point on the ground. Suppose this is that point, okay, and you've put a nail, kind of a big nail, you know, you have hammered it onto the ground, and there is a uh, suppose a jute rope, okay, jute rope. You've got a jute rope which is tied at this nail, at the center of it. Okay, ऐसे एक jute rope पड़ी हुई है आपके पास. This is like this. And if I ask you to draw a circle out of it, what will you do? This is tied at this end, okay? This is tied here. What will you do? If I ask you to draw a circle, and this is real ground, you're standing on the real ground. Okay, suppose you are here. Okay, how will you draw that circle? Okay, so what you will do is, this is a very simple exercise of drawing a circle. Okay, so what you will do is, suppose you're so you will straighten this jute. Say you खड़े हो आप. Okay, you'll straighten this jute rope and you'll just, because this is tied, ये जो बीच में है हमारा ये, this is tied to the ground, tied, or you can say nailed on the ground. Okay, nailed on the ground. Or let me take it with a different color. First of all, I'll erase this. ओके, ये है. सो विल सी, ये जो है इसको ऐसे लिख सकते हैं, nail on the ground. So now how will draw, you will draw it. Suppose you're moving on this side, है ना, ऐसे घूम रहे हो आप इसको लेकर. इस तरह से आप लेके घूमोगे अगर, है ना. इट शुड नॉट बी, string should not slack, it should be tight. Okay, suppose you're like this, you must be getting the feel of it. Okay, इस तरह से आप जाते जा रहे हो उसको लेके. This is how it will form. Okay, a circle will form. The shape is not that correct. Okay, can I use the shapes? Just wait. Okay, like this. This is a perfect one. Okay, okay, so even on the paper also, if you see, just wait, let me just, okay, so this is the center of it. ऐसे ले लेते हैं. Okay, so this is a radius, RADIUS, radius. Okay, this is the radius. Why this is radius? If you can see that I have attached that rope, jute rope, to this nail which I have like fixed on the ground. So when I am taking it and the string is not slacked, okay, so it is tight. So when I am rotating it, so always the string is the same. Okay, it is the same distance because that is the single string. And when I'm rotating, I'm at the end of it, I'm getting a circle shape. If I see it from above, I'll see a circle. Okay. How did I like get that circle? Because that string was there. It was of constant distance. Okay. So that is called as radius. So now you can always think, if this, suppose this is point O, O is the center. Okay. O is center. CENTRE. Okay. O is the center. So that is the radius is always constant because it is the same string, and I'm rotating it, so I'm getting a nice circle. Okay, so same experiment you can do it on your page also. You suppose you've got a compass and you put the one pointed thing at one point on the paper and you rotate other. Okay, you have a pencil at the other side and you're rotating that, so that is the same thing, you'll get a circle. So if you have got a single rope and somebody asks you to draw a circle, you can easily do that. Okay, just fix that rope to some end and make because wherever you will fix, keep that point, that point will act as a center, and just rotate around it. Okay, and if you've got a paper, you can do it through a compass also, maybe through your hand also, but string should not slack. Only then it will be at the constant distance from the center, and that constant distance is called as radius. So now suppose from the O, from the center itself, suppose if I draw any line from OA, suppose I am drawing this line, okay, till the boundary of it. Okay, so will it be the same as radius? Yes. Okay, so these all will be the radius, okay, of the same length. Okay, so all are of same length. So this way you can have, and you can do this experiment anytime. Suppose you're on a ground, you have some rope and you have a nail, you just try this experiment. Okay, and once you're moving across taking that string, you just have a line on the ground. Okay, maybe it's an open field, you just have that, and at the end of it you will see a nice circle. Okay, so this is how you can make it. Okay, these are secant, tangent, intersecting these things. Okay, now we will see okay, the tangent at any point of the circle is perpendicular to the radius through that point of contact. Okay, suppose if we see, this is kind of a theorem. Okay, एक तरह की theorem है ये. Suppose okay, suppose this is a center. Okay, Okay. So this suppose there is a this line, green line, suppose its name is AB. Okay, this is a tangent. AB is a tangent. So what is the property of the tangent? Tangent will touch the circle at only one point. Okay. So if we see at the point P, there will be only one tangent. You cannot draw another tangent. That won't be possible. Okay. At one point of the circle, you will have only one tangent. And at point P, this is the tangent that I have drawn, AB. Okay. So now if we are drawing, suppose this is point O, okay. O is the center, and if you see O and P, so O and P, what will be the length of OP? What it would be? Will it be radius? What do you think? Because the property of the radius is the line from the center to anywhere on the body of the circle. Okay, so it is like OP. P is at on the circle. P point is on the circle. So OP would be, it would be radius, right? R radius. Okay. Now suppose if we take any point Q, यहाँ पे हमने Q लिया है कोई भी point, okay, or if we're drawing like a line like this, okay, so definitely this distance of OQ would be greater than OP. That is what you will agree. Okay. Okay or not? OQ would be greater than OP always. Okay. And as and when you're taking this point nearer, suppose ऐसे करके है ना, okay, like this. If you're taking this point Q towards it, so all these angle, okay, so OP will be the shortest of it. Okay. So which will be the shortest distance? किसी लाइन से जो shortest distance होता है वो कौन सा होता है? For example, suppose you take this one. Okay, ये कोई line है, मतलब perpendicular होता है, right? Suppose this is a line at the bottom. ये एक तुमने इसके ऊपर draw करी, फिर एक ये draw करी, और एक ऐसी draw करी line which is at the shortest distance from that line. Suppose ये point O है. Okay. Radius तो है ही, but what we are seeing is कि वो shortest distance जो है वो perpendicular होता है. Okay. ऐसे ये, क्योंकि triangle also देख लो, if this is the shortest distance in this triangle, this is hypotenuse, that is the base. Okay, this is perpendicular. Okay, are you getting that? But theoretically, when you're drawing these lines, okay, hypotenuse, suppose you are like taking it inside, at one point of time it will be the shortest distance. So now the hypotenuse would be bigger than radius, than this perpendicular distance. The next line if we see, okay, ये दूसरी देखते हैं हम, ये पहली है मान लो, okay, ये पहली है, ये दूसरी है, ऐसे करके. So like this, if we are taking these things, so hypotenuse would be greater than this perpendicular distance, which is the shortest distance. Okay, and once we are reached this point, okay, once we reach this point, and if we are moving away, ऐसे करके, ठीक है, तो फिर से ये elongate होना शुरू हो जाएगा ऐसे करके. Okay? So this is the shortest distance. So shortest distance with that line is always perpendicular. Okay. ठीक है. So this is the radius also. So the theorem is like the tangent at any point, किसी भी point पे there is only one tangent. This is first thing that you should know. किसी भी point पे if you draw a line which is like touching the circle at one point, that is called as tangent. Okay, and you can have only one tangent at one point, no other tangent, just single tangent. So at point P I have drawn this tangent. Okay, so if I draw the radius from the center to that on that tangent, so that will be perpendicular. Okay, always. You take any other tangent and you draw the radius on that tangent at that point where the tangent is touching the circle. So that will be always perpendicular. Okay, it will be the shortest one. So you can see from the triangles also, this is hypotenuse, this is base. Slowly base is getting 0. Okay, hypotenuse is there, hypotenuse is also changing, base is changing, and this is the shortest distance. Okay, so at one point of time hypotenuse will become this shortest distance, and then again if you are going away. Okay, so this point, whenever you draw a line from any point, and if it is the shortest distance towards that line, so that will always be a perpendicular. Okay, to that line. कभी भी देख सकते हो. More closely also you can see. देखो, जैसे एक line है, and this is a point, suppose. And if I draw this line, ऐसे, okay, is this the shortest from this point O on this line? Is this the shortest distance? No. You can always draw another line which is little shorter than this, है ना? Which is little shorter than this. Where I'll ask that whether this is the shortest distance to this line from point O, you will say no. You say that I am drawing the third line. Okay, this is even smaller. Okay, you take it, this is even smaller. Okay, now you're saying this is the smallest one. Are you seeing? You cannot draw any line from point O to this line. Line's name is suppose AB. Okay, which is shorter than this. ये जो P point पर आ गया, P, let us take the P point. Okay, इससे short नहीं कर सकते आप. फिर आप if you go away from it, so फिर they will like start increasing. Okay, देख सकते हो आप, will start increasing. Okay, so this point P, this is the shortest distance, and this is always will be perpendicular. OP is perpendicular to AB. Okay, so always remember this thing. So 2 points you've got to know. One is like tangent, there is only one tangent, okay, at any point of the circle. All the circle definition is all the points on the circle are at the constant distance from which point? What is that point called? O point, what is that called? O point is called as center. Okay, same thing over here also. Okay, if we are drawing any line from O to any of the tangents, okay, tangent is touching the circle at one point, suppose P. If you're drawing that line OP, so OP would be radius, and on the line it will be the smallest distance, and but it will be the radius of the circle. Okay, and it will be always perpendicular. We've seen. Okay, now suppose we take another scenario. Or you can say that just take the smaller one. Okay. Now we are drawing these two lines. Okay, suppose here I am taking another line. something of this sort. Okay, take it as these are straight lines. Consider these as straight lines. Okay, now suppose this is point O. Okay, so if I take this point, outside point as like P, suppose this is P. Let me like rub it and do it again. It's not good. Okay. This is point P, suppose. This is any point outside, okay? What are the three scenarios? There was a line outside which is called non-intersecting. When the line is inside, it is intersecting the circle at 2 points, okay? And there is in between a line which is the tangent, okay? So in this case, we are taking these two tangents. So if we are taking any point outside the circle, and if we draw two lines means two tangents if we are drawing, okay? Suppose this is T1 and suppose this is T2, okay? From point P, we are drawing two lines which are touching the circle at only one point. This is a possible scenario, okay? तीन नहीं कर पाओगे आप. Do you think can you draw three tangents from any point outside the circle? Of course, you can draw one tangent, that is possible. You can draw from the same point, you can draw another tangent also, but you cannot draw the third tangent, okay? So from any point outside the circle, if you see practically, you can have two tangents. Getting it? Suppose this is the center. Okay. If I am drawing from the center, suppose to the point P, okay, and I am also the point where it is touching, वो भी कर रहा हूँ मैं ऐसे. Getting it? And this is point O. T1 and T2, okay. So what do you think would let me take these points as maybe Q and R. Let me just erase them. Okay, first of all, let me take so this is Q and this is R. Okay. Q, this is R. Okay. So what are these? This was T2. This was T1. The tangents हैं दो अलग-अलग, and they are touching the circle at point Q and R. Getting it? Now what would be the distance of OQ? कितना होगा OQ? And OR also. Can you tell me? Tell me. Can I say OQ is equal to Can I say OQ is equal to OR? Can I say this? Can I say this? OQ is equal to OR. O is the center and R is the point where the tangent is touching that circle. Q is also that point where this tangent T2 is touching the circle. Okay. So if I draw these two lines, these two would be perpendicular, definitely. Can you see that? तो perpendicular होंगे ऐसे. Okay. दोनों perpendicular हैं. Now OQ is equal to OR. If I say, is it true or false? OQ is equal to OR.
Sir, yes, sir, it's true. Sir, they are
It's
radius
true.
only.
They are the radius only, right? Very true. ये equal to मैं इसे radius ही लिख सकता हूँ. Okay, they are the radius only. R. which is यहाँ पे भी लिख सकते हो R. अब अगर okay R. If suppose I take these two triangles, I'm taking triangle कौन कौन से OPR, OPR and I'm taking triangle OQP, OQP. Getting it? In this, if I say that OQ is equal to OR, वो तो बराबर हो गया, okay? And which is also perpendicular to that line, to that tangent, ठीक है? So if I say OP, OP is common. Can you see? Can you see? OP is common for both the triangles. OP is equal to OP
Yes, sir.
दोनों में, है ना? तो ये दोनों बराबर हो गए, OQ भी बराबर हो गए. Triangle is a right angle. Which side will and now is remaining? PQ and PR. So do you think a PQ would be PR? PQ is equal to QR. Can I say that? What do you think? Apply your logic.
Sir,
देखो दी हाँ बताओ.
yes, sir, it's sir, yes, sir, it's equal.
सेम होंगे. सेम होंगे. क्यों होंगे? क्योंकि both are right angle triangle. Okay. So if right
सर
angle triangle, if
कॉन्ग्रुएंट
I
हो गए
see,
ना वो.
हाँ, लेकिन अगर आप देखो ना ट्राइंगल के उससे भी देखो, so OP
सर
is the
अगर आप
hypotenuse.
कॉन्ग्रुएंट प्रूफ कर देते तो सर एक तो ये वाला एंगल दोनों में सेम है सर, एक लाइन भी कॉमन है और क्यू मतलब सर ओ क्यू इक्वल्स टू ओ ओ आर, तो सर उसी वजह से फिर ये भी कॉरेस्पॉन्डिंग पार्ट्स.
हाँ, but if you see from the right angle triangle point of view also, let us use the Pythagoras theorem. Okay, OQP is the right angle triangle, right? So Pythagoras theorem if you see the OP is the hypotenuse, okay, and OQ is the perpendicular and QP is the base. Okay, so if I say OQ square plus QP square is equal to OP square जो hypotenuse है, और वो दूसरी side भी same है. Can you see that? In the another triangle OPR, in triangle OPR also, if you see OP square is equal to OR square plus PR square, वहाँ पे भी, and OR is equal to OQ, वो तो दोनों रेडियस ही हैं, ठीक है? So definitely by Pythagoras theorem also PR should be equal to PQ, ठीक है? करके भी देख लेते हैं एक बार. Triangle OQP, triangle OQP, okay, by Pythagoras theorem. Pythagoras theorem. Okay, OQP, OQP. OP square is equal to OQ square plus QP square. ठीक है, ये तो ठीक ही है. Okay. If we see in triangle, what is the other triangle? OPR. OPR. Okay. OPR triangle में देखते हैं. Then PR. Okay. ये मैंने कुछ गलत लिखा है इसमें. OP स्क्वायर क्यों लिख दिया? हाँ, OP is okay. ठीक है. OPR में यहाँ पे देखेंगे तो if we see OP square is equal to OR square. Okay. OR square plus what is the next one? RP. RP square. Getting it? Now if we see, I'm just underlining which are equal with the same color. OP is equal to OP हो गया. Okay. Next color let us take. I'm taking as yellow color. OQ is equal to OR. ठीक है, ये भी ठीक है because both are radius. And what is, अब आप खुद ही सोच सकते हो. ठीक है, if I write like QP square is equal to, it will become OP square minus OQ square आ जाएगा. और नीचे वाले में भी if I write RP square is equal to OP square minus OR square. ठीक है, तो ये हमारा ये वाला हो गया. ओके. So we can write like QP square is equal to OP square minus OQ square. ओके, ये हो गया. दूसरा हो गया RP square इक्वल टू OP square माइनस OR square. ठीक है, ये हो गया. अब OP सेम है, QR इज इक्वल टू OR, तो ये दोनों भी सेम हो जाएंगे. ठीक है, ये भी इक्वल टू हो जाएंगे दोनों. गेटिंग इट? QP square is equal to RP square. ठीक है, getting it? Or you can say QP equal to RP. ये हो गया QP is equal to RP. Getting it? This you can see easily from Pythagoras theorem. Also you can say, with a very layman's term, Pythagoras is always like handy. Okay, just try to see from that point. Okay, OR is equal to OQ, OP is common, so QP also is. So what we see from here, if there is a point outside the circle and if we are drawing two tangents, okay, maximum we can draw two tangents from that. So definitely wherever they will touch, and if there are two triangles, so definitely where they are touching, so that point is equal. Okay, so PR is equal to PQ. Those two sides will be always equal. Getting it? ये लिख दिया मैंने, इक्वल टू लगा दिया दोनों. ओके, QP is equal to PR. Okay. Simple proof it is. Okay, it is not requiring any like complications. Just apply Pythagoras theorem on both the triangles and just see for yourself. Find out QP square, find out RP square. If you'll find, you'll see that OP is equal to OP, OQ is equal to OR, and so QP is equal to RP. Okay, always remember this. So what were the things that we studied? एक तो, let us recap a little bit. These are the things. Okay, outside is non-intersecting line, second is tangent, which we are already studying, and one which is inside cuts at the 2 points, which is called a secant. Okay, smooth and aerodynamic shapes. Okay, so next we have seen that there is a center. Always there will be a 1 point uh, in the circle from which the distance of any line to the boundary is equal, and that is called as center. Okay, so O here is called the center of the circle. And what is the distance, constant distance called? That is called as radius. Okay, ये radius हो गया, ये हो गया. ठीक है. So now if you want to draw a circle, suppose for an exercise you are on the outdoor field, maybe you are on a cricket ground, okay, and you've got a nail or maybe any wooden thing, okay, so you're just fixing it on the ground and you've got a jute rope, and just take that rope and tie towards that, okay, to that nail or to whatever the wooden block you have, and just do not slack that string and just like rotate, okay, and have like make some mark on the ground, and at the end of you will see a nice circle. Okay, so you can yourself see that rope, which is like not slack, that tight rope is acting as a radius. Okay, because you are allowed moving, taking that rope in a circular fashion. Okay, so that rope is acting as a radius, so that is definitely a radius, and you are getting a circular shape. So this principle, you know, once you know the practical thing, suppose somebody has given you a thread and they want to make a circle out of it, circular area, you will see, oh, I cannot make it. No, you can make it. Okay, you have to just tie it from some point and take that as a center and just rotate it. So in compass also you do the same thing in your books, okay, in your copies. So that is how. So this practical aspect I am telling you explicitly because generally this will go a long way with you. And even these days also I see, uh, once you know this practical approach, if you like are facing any problem in your life, maybe many a times these things come handy. Okay, once you grasp the practical aspect of it, though we are studying this secant, tangent, you know, this is radius, this is that, but this is the practical scenario. You are on a cricket ground, you have gone on a Sunday, nice Sunday, sunny Sunday, okay, to play the cricket, and you just wanted to have a circle, okay, big circle you wanted to make. Okay, so you can just try these things out by yourself. So these gives you practical experience. Okay, so once you know this is also kind of a knowledge. Okay, I can make a circle out of a string. Okay, I do not need any other thing, and I just have to rotate. Okay, so that is one. And circular shape is everywhere. Okay, you see the sun, you see the moon, they are all circular shape. Though if you go close you might find like little difference, but from the very far away you'll see the circular shape. Wheels also, chapatis, etc. I mean circle is everywhere. Okay, so this is very very important. So whenever a circle comes to your mind, you always get two things in your mind. Always think, close your eyes, think of two things. One is center, okay, another one is radius. From center, if you drawing any line on the boundary of the circle, okay, this is called as the radius. Okay, it is of the constant distance. Now we come on the tangent part. Okay, what is the tangent? Suppose the line is non-intersecting line, which is like outside the circle. If you're like taking it closer to the towards the circle, so it will touch somewhere on the circle. Wherever it will just touch at one point. Okay, no 2 points. One point, there will be only one line, that is called as tangent. There will cannot be any other line. Okay, and what is the minimum distance? If you take the distance from O to, if you are following that, suppose you are connecting that from point O, to that tangent to that point wherever it is touching the circle, so that is called as radius. Okay, it will always be perpendicular, that also we have seen. Okay, how it will be perpendicular we have seen. Shortest distance to any line is always perpendicular. If you have got any line and if you have got a point outside that line, and if you are like drawing a shortest distance to that line, so it will always be perpendicular. Always remember this. Okay, this is one aspect. And then we are taking this, suppose we are taking an outside point, tangent was one point, now I'm stretching that point outside, little outside, it is point P. Okay, and from that point, if I am drawing the tangent, if I can draw one tangent, that is possible. I can draw no tangent, that is possible. I can draw two tangents, that is possible. I draw three tangents? No, that is not possible. Okay, from an outside point you can always draw two tangents. You can also visualize, it is very easy to see. And if we join in this, you can see the figures in this. Okay, so we have got OP. If we have got two triangles, two right angle triangles. Why right angle triangles? Because OQ will be perpendicular to T2. Okay, and similarly OR will be perpendicular to T1, so both will be the right angle triangle. And right angle triangle, if you apply the Pythagoras theorem, you can easily see that PQ is equal to PR. Okay, getting it? So this is one thing. Getting it? So this is coming to a close. Only one thing is remaining. Just wait, huh? Okay, we'll take another scenario. So I've got, like, this was my last slide. Let me just close it. There's another case. Let's do that also. Okay, suppose this is one scenario. Taking another one. Okay, suppose something of this sort. These are two concentric. Okay, let me take the point as this is the center of it. Suppose point O is there. Okay. Okay. And suppose there is one line also from O. Same another things. Okay, now see the points. Suppose ये A है, ये B. Okay. Take this as these are two concentric. How do you define the concentric circles? They both have the same center. Okay, inside circle. Suppose that is, suppose this is C1 and this circle is C2. Okay, so both are concentric at the same point. Okay, they have the same center. And now if there is a chord, okay, AB is called as chord. Okay, so the scenario is like this is touching the smaller circle at some point. Suppose this point is P. Okay, so what does the rule of tangent say? So this will be if I am drawing any line from O to P. Okay, and if AB is the tangent on the smaller circle, so will this be a perpendicular? What do you think, based upon our discussion till now? OP, will it be perpendicular to AB or not? True or false?
Sir, true.
True. Okay, so that will be perpendicular. ये तो principle अपनी जगह पर है. Okay, so now we are saying this is the chord. Okay, AB, it is touching the circle, outer circle at 2 points A and B, and it is also a tangent. The very special case, it is also a tangent to the concentric circle. Okay, so now what do you think? AP is equal to PB. Can we prove that? AP is equal to PB. Can we prove that? What do you think? Apna try like Pythagoras theorem or something. See, the triangle might seem a little different. Okay, let me just draw it again. Okay. Okay, कुछ कुछ ऐसा समझ लो. So in this case, if I say OB, OB is equal to OA, can you say that? Tell me. OB. First of all, do you agree that these two triangles OPP and OPA are they right angle triangle both?
Yes, sir.
है ना? दोनों right angle triangle है. Okay. ऐसे दोनों right angle triangle है. So if I say that OB is equal to OA, am I right or wrong? OB is equal to OA. Is it true or false? देखो those two all the both these circles are concentric circles. They both have same center. Okay. So now if I say that OB is like touching the boundary of the outer circle C1. So OB should be radius. Is it not? And OA is also touching the outer boundary. Okay. From the center I am drawing these two lines. So OB should be equal to OA. Is it not? Both these hypotenuse are equal for these two triangles. Getting it? And OP is the common one. OP तो दोनों में same ही है. Okay, OP is OP, right? What is remaining is AP and PB. Will they be same? What do you think? Tell me. In triangle OAP, OPA and OPB. In triangle OPA and OPB. OPA and triangle OPB. ओके, दोनों में अगर हम देखते हैं तो OPA में फर्स्ट ऑफ ऑल विल सी ट्राइंगल OPA. ओके, ट्राइंगल OPA में OA square is equal to AP square plus OP square, AP square प्लस OP स्क्वायर। ओके, ये हो गया। तो AP कितना हो जाएगा, AP स्क्वायर इज इक्वल टू OA स्क्वायर माइनस OP स्क्वायर। कैन आई राइट दिस? अब नाउ टेक ट्राइंगल OPB,
यस सर।
OPB। ठीक है, OPB में देख लो, OPB, अगर OPB में देखोगे तो OB स्क्वायर, ओके, OB स्क्वायर is equal to what, OP square plus PB square, or you can say that PB square plus OP square। ठीक है, PB square plus OP square। okay, now if I find PB square is equal to, can I write like OB square minus OP square? ठीक है, getting this? I will write these two equations on the next page and then we will compare. Okay, AP square is equal to AP square is equal to OA square minus OP square। okay, OA square minus OP square, ये इक्वेशन फर्स्ट है। लेट मी ये बाद में लगाता हूँ। व्हाट इज द नेक्स्ट इक्वेशन? PB square is equal to, okay, PB square is equal to OB square OB square minus OP square। ठीक है, so if I compare these two, OA, if I say, let me put the green color, this is first and this is 2। okay, comparing, these are some of the things that you will have to learn, okay, and these are some of the small proofs comparing the two। तो अगर इसमें देखें तो OA is equal to OB, can I say that? Do you think OA is equal to OB, that is the radius of the outer circle, right? OA is equal to OB is true। ठीक है, OP is equal to OP, वो भी ठीक है। ठीक है, so in that scenario we can say that AP square is equal to PB square, or AP is equal to PB। ठीक है, AP is equal to PB। getting it? देख लेना आराम से, है ना, हो सकता है थोड़ा सा समझ में ना आए कभी कभी। So now if we see on this, AP is equal to PB, so can we say that this chord AB is bisected at point P? Can we say that? This chord AB is bisected at point P. Bisected, you understand? Divided in two halves, equal halves. Okay. So always remember, when you have got two concentric circles, concentric means they have the common center, which is I've shown with O. Okay. And I'm having a chord which is a tangent to one of the inner circles. Okay. So if I draw a perpendicular, that will be the radius of the smaller circle, OP. And if I'm joining O with B and O with A, so both will be the radius of the outer circle. So in that case, that chord will always be bisected. Okay. So this is one of the things you can apply it practically, maybe, and at any time. Suppose you are dealing with some geometrical shapes, okay, some engineering design problem you're facing, okay, so you can have these things handy, okay. Just try to grasp this, and once grasped, it will go a long way, okay. So this line will always be divided in two parts. You do not have to prove it again and again, just take it, okay. How it is, we have shown it meticulously in these things, you can see, okay. These are Pythagoras theorem basic proofs. So Pythagoras theorem is very handy, okay, always remember that. Instead of going for anything, just go for Pythagoras theorem, okay. Okay, OA square. ठीक है, AP is equal to PB. Okay, there could be some other things, and then we'll take in the our next class on this. Okay, might will take some problems, and we'll take some scenarios. Some proofs could be there. Let me see. Okay. With this, I'm closing this lecture for today.
Okay, sir. Thank you, sir.
Okay. See you. Take care. Bye.
Hello. Thank you, sir.
Yeah. Yeah. Bye. Thank you.